right here we're looking at section 10.5, and our learning targets for today are to find angle and arc measures, and then we're going to use circumscribed angles. So let's first look at our first theorem. So here's our theorem 10.14, so the tangent and intersected chord theorem. So if a tangent, and remember a tangent touches a circle at exactly one place, and a chord, right, a chord just cuts through that circle. If they intersect at a point on the circle, then the measure of each angle is 1/2 the measure of the arc. So here I'd see that the angle 1 is going to be half the measure of this arc AB, which you see in red, and the measure of angle 2 is going to be half the measure of the arc here of BCA. Okay, so this is just one thing we have to remember, that if I have a line that's tangent to my circle and a chord in that circle that intersects that tangent line on the circle, then I know my angle is half the measure of the arc. So let's look at an example. So line M is tangent to the circle. Find the measure of the red angle or arc. So here I see I've got my tangent line and I've got my chord that intersects on my circle. So I see I've got my angle that I'm looking at and the arc length that I'm looking at. So I know that the angle is half the measure of the arc, so I can go ahead and plug in what I know. I know the arc length is 130 and the angle is half of that, so my angle would be 65 degrees. So in this second part of the example, again I see I have a line that's tangent to my circle with a chord that intersects on my circle. Here I'm asked for the length of the arc measurement where I'm given the angle. So I know that the angle is half the arc, so I know I have to multiply my angle times 2 to get the arc length, which would be 250 degrees. So here are some that I want you to try and just think about them. So here's our first core concept when I've got intersecting lines and circles. So we're talking non-parallel lines, right? So the lines have to intersect. There's 3 places where those lines can intersect. They can intersect on the circle, which we have talked about in our last couple of sections. They can intersect inside the circle, or they can intersect outside the circle, right? Those are just the 3 possible places where our 2 lines can intersect. So here we're looking at what happens when those lines intersect inside or outside the circle. We've talked about when they intersect on the circle, that's an inscribed angle. So we can follow those rules when it's on my circle. So now let's first look when my lines intersect inside the circle. So the measure of each angle is 1/2 the sum of the measures of arcs intercepted by the angle and vertical angle. So here we're looking at vertical angles a lot. And remember, vertical angles are the ones that are across from each other. So let's look at angle 1 right here. So angle 1 is kind of intersecting with this arc, and its vertical angle is intersecting with this arc. So what I do to find the measure of angle 1 is I add the 2 opposite arcs and then I divide them by 2. So same thing here with for the measure of angle 2. I take the 2 arcs that are intersected here, I add them together and divide by 2. That's always my rule if I'm inside the circle. So now there's 3 real possibilities if I'm outside the circle. So the first possibility is I could have one line that is tangent and that's one secant. So what I do here is to find this angle, since I know I have a tangent line and a secant line, I'm going to go ahead and subtract, right? So the measure of angle 1, I take the one that's furthest away from the angle, and I subtract the arc that's closer to the angle, and I divide by 2. The cool thing that you'll see is I do the same thing whether it's a tangent or a secant. So I take the furthest away arc, and I subtract the closer arc, and I divide it by 2 to help me find the measure of the angle that's outside of the circle. So even here, even though neither of these lines are tangent, I take the further away arc minus the closer arc and then divide by 2 equals this angle. Right? So here are those formulas that we can use, or we can just kind of deal with the things that we know. So let's look at an example here. So first I have to find the value of x. So the first thing I notice is that my lines intersect inside my circle. So I know I'm going to be dealing with the arcs that are opposite that angle that I'm looking for. So here's my angle, and I see I have this arc right here, KL, and I have JM. So I know to find those, I have to use my theorem. So I add up my 2 arcs. Since I'm inside my circle, I add my 2 arcs and divide by 2. Well, so I add the 2 arcs and divide by 2, which this angle measurement then gives me is 143 degrees. So now let's look at this B. So here my lines intersect outside my circle, okay? So since we're outside the circle, I know I'm going to be subtracting. Here when we were inside the circle, I add, Outside the circle, I subtract. So I take the arc furthest away minus the arc that's closer and divide by 2. Right? Arc that's further away minus the arc that's closer and divide by 2. So it's a 51-degree angle. That's the biggest thing you need to remember, is that inside I add, outside I subtract. So now here's a couple for you to try. So now we can look at a circumscribed angle, right? And this was our second learning target. So a circumscribed angle is an angle whose sides are tangent to a circle, right? And tangent means it touches in one place. So each of these rays touches the circle at exactly one place. So the cool thing we know about that is that this can help us find some angle measurements as well. So the measure of the circumscribed angle is equal to 180 degrees minus the measure of the central angle that intercepts the same arc, right? So I know that the arc from this ADB that's intercepted is AB, so I can draw my central angle to intercept that same arc, and I can subtract that from 180 to find the measure of angle D. And I can do that because I know that a line that is tangent to a circle intersects that radius at exactly 90 degrees. So I know I already have 180 degrees out of my quadrilateral that I've created. So I know I always do 180 minus my central angle will give me this circumscribed angle. So let's look at an example. So here I see that ADB is going to be my circumscribed angle because it's tangent on both sides of my circle. I'm given the central angle, which is 135. So to find the value of x, I go ahead and I use that central angle, circumscribed angle theorem, and I subtract it from 180, which gives me 45. So now let's look at the second example. The second example is a little more difficult. So here again, I have my circumscribed angle. I see I don't have the central angle here. I have an inscribed angle. And remember, an inscribed angle is where my vertex is actually on the circle. So the first thing I need to do is I need to figure out what the measure of this arc is, which would tell me the measure of the central angle. So there's one more step in this one I have to do. Okay, so I know with inscribed angles, the angle is half the measure of the arc. So I can go ahead and plug in what I know and find what I have. Okay, so the angle, and here's the only difference, right? I was looking at my angle, EJF, is 1/2 of the measure of the arc. But I also know that arcs and central angles have the same measurement, so I can just substitute here. Well, so now I know I'm looking at going to be 180 minus that, so I substitute what I know and I can simplify. So x is 75. So here's how I would do this, is kind of looking at exactly what we have following this around. Okay, so make sure that you can do a problem like this and find where all of your pieces go and find what happens and what you're going to do with them. So now here's kind of our real world example. So the northern lights are bright flashes of colored light between 50 and 200 miles above Earth. A flash occurs 150 miles above Earth at point C. What is the measure of arc BD? The portion of Earth from which the flash is visible. So the Earth's radius is approximately 4,000 miles, right? So if the flash happens here, I can see it from points B and points D and anywhere in between. So I have to figure out how much space I can see it from. Okay, so I'm given the actual height of this and the length here. Okay, so I'm going to make my plan and kind of go with it. I know that those are tangents to my circle because it's the furthest place and it hooks at one point. So I know that these angles right here, angle B and angle D, would both be right angles. Okay, so I also know that BC is going to be congruent to DC because they're external tangents to the same angle, right? That's what this part, external tangent congruence theorem, was. They come from the same point and they're both tangent to the same circle, so they are the same length. I also know that CA is the same thing as CA, right? Because it's the same line. So now I see that I have two congruent triangles that I'm dealing with, right? With all the information that I have. So now I can look at corresponding parts of my triangles so I can find the angles that I'm missing. Okay, and now I can look at my circumscribed angle theorem now that I have some angles, and I can take my 180 minus that measure of my minor arc, and I substitute the things that I know and solve for that. So the measure of the arc is about 31 degrees once we've gone through all of these pieces. Okay, so make sure that you can look back and kind of follow what we've done here and how we've gotten those pieces. So now here are some for you to try. I'd really love for you to spend some time on this word problem because we're going to be dealing with word problems pretty often here. So now we are going to go look back at our learning targets. Our first learning target was to find angle and arc measures. The biggest thing when we're looking at here is where our lines intersect, whether it's inside or outside the circle, because that will change what we do with the measurements. Then our final learning target was to use circumscribed angles, and we can do that to find lengths, especially when we're looking at the globe and the earth. We'll do that pretty often. So now that we've looked up these learning targets, go ahead and work on your homework for 10.5.